When it comes to maxillofacial surgery, few challenges are as demanding as repairing a fracture of the mandibular head. For decades, surgeons worked with imperfect tools. But a revolution is happening right now, built on a material that could fundamentally change how we approach these complex injuries.
I mean, think about it. This is the central pivot for everything we do, talking, chewing, all of our expressions. So repairing it isn't just about setting a bone, it's about restoring a person's quality of life. You need a material that is incredibly strong, but also works with the body, not against it. And for a long time, the options on the table were, well, they were seriously flawed.
So, here's how we're going to break it all down. First, we'll get a real sense of the injury itself. Then we'll look at the classic solutions, titanium and polymers, and dig into their drawbacks. After that, we'll explore an incredible breakthrough from Poland. And finally, we'll look at the hard science and deliver the final verdict.
All right, let's dive in. Just how complex are we talking here? Well, this is a tiny, incredibly important area, and it's surrounded by a minefield of vital nerves and blood vessels. The procedure to fix it, which is called osteosynthesis, requires unbelievable precision to make sure the patient gets back their full, pain-free range of motion.
And you know, this isn't some rare textbook injury. It's incredibly common. Fractures of the condylar process, which includes the mandibular head, make up about 17% of all mandibular fractures. That's a huge number. It's a serious clinical challenge that surgeons face all the time, which makes finding a better treatment an absolute priority.
So this brings us to the old guard, the long-standing gold standard, titanium. For decades, if you had this kind of fracture, you were getting titanium plates and screws. They're strong, they're reliable, and they provide the rigid fixation needed for healing. But all that permanence comes at a pretty significant biological price.
And here's the core trade-off. Yes, titanium absolutely provides the mechanical strength you need for a solid bone union, no question. But the flip side is, you're left with a permanent foreign object in your body. This implant can cause all sorts of issues, like chronic inflammation, oxidative stress, and even something called apoptosis, which is basically programmed cell death in the tissues around it. Because of all this, a second, often risky surgery is recommended just to take it out.
This quote really just says it all, doesn't it? Once the bone has healed, that titanium implant isn't just sitting there doing nothing. It can become actively harmful. And the thought of going through another operation with all the risks that come with it is a huge burden for everyone involved.
Okay, so if a permanent implant is the problem, the logical next step is to find a material that just disappears when its job is done, right? This line of thinking led to the development of resorbable polymers. And on paper, it looked like the perfect answer. In reality, though, it was a whole lot of compromise. So while these polymer screws did solve the permanence problem, they brought a whole new list of complications to the table. For one, their mechanical strength just wasn't enough for the high-stress environment of the mandible. On top of that, their degradation process was incredibly slow, sometimes taking more than 5 years, and could trigger nasty inflammatory reactions, painful fistulas, and even osteolytic lesions, which is the literal destruction of bone. Not good.
So you can see the dilemma surgeons were in. Do you go with the strength of titanium and accept the risk of a second surgery? Or do you choose the resorbability of polymers and risk mechanical failure and inflammation? It was a classic rock and a hard place situation, and it perfectly set the stage for a third way, a material that could finally offer the best of both worlds.
This search for that third way for the Holy Grail led researchers to reabsorbable magnesium alloys. This material had the potential to give you the strength of a metal, but with the incredible ability to dissolve safely and integrate right into the body. And a major key innovation in how to use it came from a team in Poland. Okay, so let's look at how this unfolded. The first time magnesium screws were used for this was in Germany back in 2017, but those were cannulated or hollow screws. The real game changer came 2 years later in 2019. That's when Polish authors became the first to develop and clinically use solid magnesium screws, which gave them much better mechanical integrity for such a demanding surgery.
And let's be really clear about this, because it's a critical point in the story. This move to solid screws was the key that unlocked the material's full potential, and it was a true milestone pioneered by that Polish research team.
And this wasn't just a theory, it's been proven in practice. Clinical evaluations by surgeons in Poland started 2 years after those first surgeries, and they confirmed excellent results. Now, with about 3 to 4 years of data, the success and the reliability of this technique are well established. It's proving to be a truly superior alternative.
So how does magnesium really stack up against titanium and polymers when you look at the science?
Let's put these three materials head to head and see what the clinical data tells us.
Okay, this table really tells the whole story. First, mechanical strength. You can see magnesium matches the high strength of titanium, something polymers could never achieve. Second, is it resorbable? Yes, just like polymers, which means no need for that second surgery. But then, look at that third row, bone healing. This right here is where magnesium goes from being just an alternative to being a true upgrade.
You see, unlike titanium, which is basically inert, or polymers, which can cause inflammation, magnesium is what we call osteoinductive. That's a fancy word, but it means it actively encourages and promotes the formation of new, healthy bone. It also has natural anti-inflammatory and antibacterial properties. And on top of all that, its stiffness, its Young's modulus, is much closer to actual bone, which reduces stress on the healing fracture.
And this isn't just a theory. We have clinical studies using radiological analysis that have actually demonstrated this. Fixation with magnesium screws leads to a measurably higher density in the healed bone compared to fixation with titanium. It's not just that the bone is healing, it's healing better.
So what's the bottom line for the patient? It's pretty straightforward. You get a stable, strong repair that leads to higher quality bone, and you get it all from a single surgery. It solves the titanium dilemma and the polymer compromise in one elegant biointegrative package.
This breakthrough really forces us to ask a much bigger question. If we now have a material that gives us metallic strength, but then safely vanishes after it's done its job, all while helping the bone grow back stronger, are we witnessing the beginning of the end for permanent metal implants and reconstructive surgery? The evidence from the mandibular head certainly suggests the revolution is already here.